'Cause you need to get back in the arms of a good friend. And I need to get back in the arms of a girlfriend. I didn't know nobody, and then I saw you coming my way. I didn't know nobody, and then I saw you coming my way. Don't you need to get back in the arms of a good friend? Oh, 'cause honey, believe me, she'll love to call you my girlfriend. Don't you need to get back in the arms of a good friend? Oh, 'cause honey, believe me, she'll love to call you my girlfriend. 'Cause you got a good thing going, baby. You only need somebody to love. Well, you got a good thing going. You're only looking for someone to love. 'Cause you need to get back in the arms of a good friend.
All right, so today we're going to continue on SQL. We're going to do a little bit of a review, but before we do that, I would like to bring your attention once again to their Gantt chart. At this point, you should have your test case written and done. It doesn't have to be big. If you turned it in for extra credit, great. For the most part, we gave at least a few points for those if you turned something in. Some of them were badly formatted, and so we had to throw them out. Some of them had bad data. We had to throw those out. Some of them didn't have output.txt files, so we awarded proportional points for those. That'll show up on your assignment 3 when that gets graded. But otherwise, we have now opened up grading scripts for the entire rest of the semester using those test cases. If you do see anything wrong with those test cases, inform us immediately, and we'll take a look. But otherwise, we didn't just use the submitted outputs. We reran those against a known correct solution, so those should all be okay. You should have started on your implementation by now. On Tuesday, we will be releasing our feedback for your design document, and that'll give you some tips on going back and fixing things and changing things if they need to be changed. Again, this is the one that people struggle with the most on design because they don't use the object-oriented programming principles that we've covered. Really focus on Lab 5. That inheritance is a good inheritance because we have state up here where it belongs, state down here where it belongs for specific types. We've got methods up here that are abstract because there's no way to answer those questions. But down here, we've overridden them to provide actual behavior. So if your design is looking something like Lab 5 or something like what we did in class, the annuity, right? The annuity, the person, the stock, etc. then you're probably in good shape, right? And all that has been posted to Canvas, by the way, or not Canvas, but GitHub notes. All right, so you should be working on that over the next couple of days, giving yourself plenty of time to do redesign, to do refactoring, to do debugging, right, et cetera, giving yourself an extra day of padding at the end here to get anything answered. Remember, don't expect a lot of help on Friday because a lot of folks wait to the last possible second to get help, and it is packed on Fridays. So keep that in mind. Your lab this week is on SQL. You'll be doing a series of, I think, a dozen or so queries, very much like we've been doing in class here with this video game database. But the database that you'll be using is the albums database. So if you've not already installed MySQL Workbench or you're having trouble installing that, make plans to use the lab computers for that lab. All right? Otherwise, that takes us up to spring break, and you'll have a good week of relaxation or whatever. Right? Okay. So to continue where we left off last time, just as a review here, we were looking at the group by clause and the join clause. The group by clause allows you to process data on the database end. For example, I want to know how many copies of each book by author, right? In other words, group them by the author and then sum up all those numbers of copies. And so the first step is to group them. If you group them by the author, then the Douglas Adams ones are together, the Norman Mailer ones are together, the Orson Scott Card ones are together. Then what you can do is you can project that down. Remember, if you take a three-dimensional object like a cube and you project it down onto 2 dimensions, you lose one of those dimensions. The dimension that I'm not interested in here is title. I'm going to lose that. But I'm going to gain a new dimension over here, an aggregate dimension on the number of copies. If I sum those up, I end up getting 13, 7, and 7. Right? And we showed an example of that last time. Let's see where it is. Right? Fine. Group by publisher. Yeah, there it was. We wanted the publisher ID and then the number of titles from game and then group it by the publisher ID. So there we weren't grouping authors, we were grouping publishers. And then we counted up the number of game IDs. Initially we had a star here, and remember that didn't work because it was counting records even though it was joining to null records. So we ended up counting the game ID to give us the correct value. Once again, let's go ahead and take a look at that. So select everything from publisher, right? Select everything from game, right? And so which table do we actually want to look at here? I want to know how many games they have. Is it going to be found in the publisher table? Nope. That just tells me that there are 13 publishers. And by the way, I reset everything to the original. So we've got 20 games over here, all right? What about the publisher IDs? If I just go ahead and group them, here's my first attempt from last time. Select publisher ID, comma, a count of everything from game G, or game, a group by publisher ID, right? Then I get something that looks like this. Publisher ID 1 is count 3. Remember that was LucasArts. Publisher ID 5, that's going to be, I think, Nintendo, and they've got 5. I'm getting the correct answer here, but is it at all satisfying to say, oh, publisher ID, I don't know, 13, they've got 1 game, right? That's not going to give me enough information to say that this game it was published by this publisher, or this particular publisher, Namco, has these many games. So what I need to do is I need to bring in a second part to this, and that's going to be a join table. Here's the example that we looked at visually, where we've got a student table, an email table, and then we join them together. Obviously, the connection here is going to be the student ID. The student ID is a foreign key in the email table that references the primary key, student ID, in the student table. Castro shows up here. Why? Because he's got 1 email over there, number 13. Rizzo, he shows up here once because he's got 1 email. Ryan Sandberger down here, he shows up twice because he's got 2 email records in this table over here. But Dale Sweem, he doesn't show up at all because that student ID is not over here. That would have required a left join. If we just do the same join, but we do a left join, then records from the left are preserved, or from the left, your left over here, right? From the left to the right are preserved, However, since there's no email record, it ends up being null. Right? So let's do that over here with the publishers. Right? So select publisher or name as publisher name, right? And then count star as number of titles. Now remember that this as keyword, that is a alias. I am temporarily, for the purposes of this query, renaming my column here so that it's more descriptive. This column here is just count star, and that's not even a descriptive variable name. In fact, that's a function call name, right? So I'm going to rename that as number of titles, okay? Now, to start, I need to go from the publisher table, right, over to the game table. So if I just do a regular old from publisher P, then, P, need to shut off auto-completion there. Join game G on P dot. Now, what's the connection between these two? Let's actually look at this, right? So what's the connection between these two tables right here? Let me zoom in a little bit. Right? So how do I have how do I know that a game was published by a particular publisher? We have a foreign key over here that references the publisher ID over here. Without even looking at this little red dot here, or this red triangle or diamond, and this little key icon over here, how do you know that that's the connection? They share the same name, right? There's obviously a publisher ID is going to share the name of the table with an ID slapped on the end. If I'm following consistent naming conventions and being descriptive, this is going to be so much easier, right? So I'm going to go ahead and connect through the publisher ID. P.publisher ID is equal to G.publisher ID. Now, do you remember what happened when we didn't have this on clause? Remember, this is a relational database management system, a relation. If you just do a full cross join and I have 20 records over here and 20 records over here, that's going to be a full Cartesian product, 20 times 20, 400, whether or not those records are related, right, in any way, right? That's not what I want. I want the relation that the publisher IDs have to match. Imagine if you did that with a record with 1 million elements and 1 million elements. Now you're going to have 1 trillion elements in your query, and that ain't running, right? Or it's not running in any amount of time that you're going to sit there and wait for it, right? So on publisher ID. So let's go ahead and end it right there, right? And fix it, right? So there's obviously an error code here. The name field is ambiguous. Remember that once I alias the tables, right, P dot name is what I want, right? Because remember, we've got a name over here and a name over here. That actually probably is a good indication that these were wrong variable or wrong column names to begin with. What should I have named this column over here? Probably title or something, right? What should I have named this column over here? Maybe publisher name, but you're already in the publisher table. I would say that once you've renamed this to title over here, it's no longer ambiguous. But what you need to do is you need to slap a P dot in front of it because I have aliased this publisher table as P. Right, there we go. LucasArts has 20 games. Is that correct? Nope. So what did I forget to do? I joined these tables together, but I didn't do the thing that I wanted to do. I didn't do the counting, right? I want to know how many there are. I want to project this down. I don't want the everything. I just want the publisher name along with the number of titles. If you're going to do that, then you need to group by. Now, what should I group by here? Well, if I'm grouping by the publisher, it's going to be the publisher ID, right? So P.publisher ID. You could do G.publisher ID, but they're going to be the same because of this on clause right here. So it'll end up with the same result. There we go. LucasArts has 3 games published. Nintendo has 5, right? Rockstar Games has 4, right? ... Now, I seem to remember that there were more publishers. For example, Square Enix, Sony Entertainment Computers, right? And Sega. They're not showing up in this report that I just wrote. So how do I rectify that? Remember that they won't show up if there's no corresponding record. If Dale Sweem over here doesn't have a corresponding record in the student table, then he's not going to show up. The way that we rectify that is using a left join, a left outer join, to preserve that record. So let's go ahead and left join this. Now again, I can't zoom in on this, but Sony Computer Entertainment, remember they didn't have any games at all. So why is it reporting that there's one game? Remember what the issue was? I'm counting every record, whether or not they're null, right? I don't want to do that. I want to count every game that's on in this report. That Namco published Katamari Damacy and this one and this one and this one, right? Those 4. But when you've got Sony Entertainment here and they've published nothing, what ends up being here? The same thing as Dale Sweem, null. I don't want to count that. So if I count game ID, g.game ID, right, that's not necessary because it's unique and it's unambiguous, but there. Now I'm counting something that exists. And if it doesn't exist, Sony Entertainment, it's going to end up being 0. When you sum up a bunch of nulls, what do you get? 0. When you multiply by null, what do you get? Probably 0. So in the context of databases, 0 has a definition. In Java, that's not the case. Null plus whatever, that's going to be interpreted as like a string concatenation. And if you add it to a primitive type, 5 plus null, that's definitely going to be a null pointer exception. In Python, if you were to do something like this with none, you're going to get garbage results too, or probably an error. It'll just error out the script entirely. Right? But in the database, nulls are treated as 0. Right? So there's our review from last time. Now what I want to do is I want to get a little bit more practice by doing a few more queries here. For example, I want to go back all the way to square one. Normally when we get, usually the first assignment is something like we give this video game data, but we give it in a flat file. You had the same exact exercise in your first assignment, but instead we swapped it out for different data this year. We generated a bunch of patient data, right? So what would this look like as a flat file? In other words, if I took this full circle, I want to take all 4 of these tables, join them all together. Up till now, I've only joined 2 tables. I've only joined the publisher and the game table. Now what I want to do is I want to take the publisher table, the game table, the availability table, and the platform table and join them all together. Right? Because I want to reproduce that flat file and what it looks like. So let's come over here and let's go ahead and come back all the way to square one and flatten the entire data model. Right? ... Now you might think, well, you could have done that to begin with a CSV file. Why did we need a relational database management system? Because again, we've solved all of these problems, right? It is a terrible format to search and consolidate. Files can only be processed one at a time. Data is repeated unnecessarily, etc. We've solved all of these problems with a relational database management system, but maybe we want to go back and reproduce a report that looks like a CSV file, right, with repetition of data. So let's go ahead and flatten the entire data model. For now, I'm just going to go ahead and select everything. Right? From publisher, P, join game G on what? On P.publisher ID is equal to G.publisher ID. Now, I remember that because I just did it up here. But even if I had not remembered that, I would remember, okay, there's a game table and a publisher table. Without even looking at the tables, how do I know that the foreign key and the primary keys are publisher ID? Because I know that the publisher table is called publisher. Slap an ID at the end. The foreign key is named after the primary key. They all share these same commonalities. Join availability A on. Now, how do I know that a game is available on a system? Because I am using the same naming conventions everywhere. G.gameID is equal to A.gameID. I didn't even have to look at that, right? I knew that the game ID, primary key over here in the game table, just had an ID at the end. Over here, the foreign key was named after the primary key. Right? Now I'm going to go over to the platform table, and I can see that it's the platform ID. So let's do that. Join platform P on, what is it going to be? P dot, or actually G, because I'm going left to right here, I'll go with G dot, or A dot platform ID is equal to p.platform ID. Now, do you see a problem immediately with this query? How many tables have I aliased to P? Publisher and platform. And so if I try to execute this, it's going to tell me, right? It's not a unique alias, P, down here. All right, fine. I'll go ahead and give this a different name, plat, short for platform. Right? There we go. And now I'll get a report there. Right? So that LucasArts published Lego Star Wars and in 2005, available on Xbox. Delphine Software published Out of This World in 1992, available on the Super Nintendo, originally on the PC. Right? ... Now wait a second. Do you see all the publishers here? I don't see Sony. Right? So let's come back and refine this a little bit more. What kind of joins should I have done? A left join? Right? Why? Because I want to preserve any publisher that doesn't have a game. Okay? So is that going to get me what I want? I still don't see Sony here anywhere. Right? In fact, if you sort it by clicking up here, you can come down here, NRV, right? So I don't see Sony here. So what's the problem? If I only went from publisher to game, this would have worked, right? In fact, let me go ahead and get rid of this and get rid of this. Right? This is what we did before. And I am getting publishers, Sony Entertainment Corporation, with null and null. But if I start at the game table with a null game ID, and I do a regular old join over here to the availability table, is it going to match anything? Is null going to match anything over here? No, because null doesn't match anything, period. So if I want to preserve all these records, I need to do left joins all the way through. Left join. Left join. And now I'm going to get all of, get rid of that. There we go. Now I'm going to get Sony Entertainment, and you see that all the way over to the platform table. They've not published any games, therefore they're not available on any platform, therefore everything all the way across is null. If I were to dump this to a CSV file, I would probably have like empty strings for those, right? Or a string like with a double quote and nothing in it or something, right? I probably would not output it as NULL, okay? Excellent, right? So I've got every single publisher here, whether or not they have any games or not, okay? All right, let's be a little bit more, intentional. For example, do I need the same publisher ID here and here? In fact, does one give me any information at all? I mean, if I had to do anything with the database, yeah, sure. I would need to know, I need to delete that publisher. I need their publisher ID. But if I'm trying to generate a human-readable table, do you want to see these magic, weird numbers all over the place? No. What I want to see is the publisher name, the title of the game, the year that it was published, and the name of the platform that it's on. So let's limit our query to just those four things. P.name, G.name, A.publish year, I think it was called, right? Let's go ahead and take a look. Publish year right there as an integer. And then finally plat, because I renamed it plat.name. Right. There we go. Now, that's much better because now I don't have any of that weird data there, right? What does it matter that the primary key is 47245, right? But now I'm just getting a bunch of strings, except that name, publisher year, name. Right? Is that a good pattern? Probably not. Let's go ahead and alias all those things as publisher, right? G.name as title, and platform.name as platform. There, much better. Publisher, title, publisher, and platform. So I've got all this, the publishers. I've got all the games because I did left joins all the way through. But now let's look over here to the platform table. Right? Am I getting all the platforms? Well, I certainly see Xbox, PlayStation 2, PC, Mac, PC, ... Right? So let me see, let me just go ahead and enter in some new data here to see if I'm preserving that data. I'm going to add something that is very, very recent. I don't know. Yeah, I'll add two things that are very, very recent. Insert into platform, name, right? Values, platform, yeah, it was platform. Why are you complaining? Let's go ahead and do, I don't know, Steam Deck. Right, there we go. And play date. There we go. All right. So everybody probably knows what a Steam Deck is, right? Pretty cool handheld system. It's giant, but you need giant for good graphics, right? And then Playdate is much smaller, old school. This little crank thing. They're both awesome, by the way. All right. So let's go ahead and execute that. Right. Now I'm going to go ahead and execute the original. Right. Now, do you see Playdate or Steam Deck here at all? Now, I see a bunch of nulls at the top, but I see Game Boy, Mac, NES, PC, PlayStation 1, 2, and 3, Super Nintendo, Xbox, and Xbox 360. Right? I don't see those brand new systems or recent systems over there at all. Why is that? Remember, I was going left to right. Left join, left join, left join, left join. That Playdate that has no games, therefore no availability, would that have been preserved going from left to right, preserving things from the left? No. There's a empty, there's an empty, or a record over here that would never have matched any record coming all the way through. So let's go ahead and rectify that. Let's write another query here. I'm going to go ahead and cut and paste this. And let's go ahead and reverse all of this. I could, as a first step here, I could say, not start at publisher, but start at the platform. Plat, right? And then do a left join to the, I'm going right to left now. Right, from the platform to the availability, to the game, to the publisher. So platform, then to the availability. I'm going to move this one up here. On game, availability, I need plat there. So plat dot platform ID is equal, platform ID is equal to a dot platform ID. There we go. And then I can go from the availability to the game table, G on a dot game ID is equal to G dot game ID. Then I can do a left join onto the publisher table, P on G dot publisher ID is equal to P dot publisher ID. There we go. Lots and lots of typing. On. There we go. All right. Now I see Steam Deck and Playdate down there. Why? Because I went to the opposite direction. I preserved things over here. Right now, if you take this ER diagram and just flip it, right, then you can see that I'm going left to right still. Right? I'm just starting at the platform table, then going to the availability table, then the game table, then the publisher table. But the problem is, what about Sony? Do you see Sony anymore? Nope. If you preserve records from one direction and then you reverse and preserve records from the other direction, now you're back at square one. Right? That Sony entertainment, computer entertainment, they're lost just like Playdate and Valve or Steam Deck was lost. Okay? In fact, there's a better way to do this. Why go left to right when you can go right to left, but instead of a left join, you want to preserve records from the right? Go ahead and do so, right. Right? I covered this last time, but I said, it's not that useful until it becomes necessary. It's not that useful because I don't read right to left, but we are doing that. I'm reading right to left now. I'm going publisher, game, availability, platform. I start at the platform, then availability, then game, then publisher. Right? And I'm preserving from the right. Right? It's kind of confusing. But you can preserve to the left, from the left, excuse me. You can preserve from the right, but can you do both? Right? In other words, I want one grand unified report that brings the results from this one and the results from this one all together. So let me ask you, now that you're doing set theory over in, say, CSCE 235, if I've got two sets, A and B, right, and I want to bring them together, right, there are several operations that you can use here, right? Cap, right, and The other one would be cup. And I'm reading out what the LaTeX is here. Right? But you tell me, what are the what are those set operations that you're probably covering in 235 right now, or have done recently maybe? What about that first one? No? It's the intersection. What about that second one? It's the union. So what is the first one? A and B. If you were to draw a Venn diagram, here would be A, here would be B. Everything in the intersection is the one that common to both of those sets. What about the union? Take everything here, and it doesn't matter if there's an intersection or not, you're taking all of them and unioning them together. Now, because sets are unique, you're only going to get unique records out of that. You can do the same thing over here. Why? Because everything is set theory based. You can union these two things together. I'll take out my semicolon, and then here, let me zoom out so it all fits a little bit. There we go. All right. And then do a union on this one down here. Right. The keyword union will take this set, the result set here and the result set here, and union them together so that you have one big giant report here. We still have Sony, Square Enix, and Sega preserved from the left. Down here, we have Playdate and Steam Deck preserved from the right. Do we have two Rockstar games, GTA 4s, 2008 on Xbox 360s though? No. I mean, we do have two such records, but one is Xbox 360, one is PC. It's different, right? So we are taking everything that is unique. What if we did the other one? Intersect. Right? It's not supported by this one. Okay. There are some SQL variants and SQL dialects that do allow that, but oh no, it did it. Right? All right. So even though, why are you complaining about it then? You shouldn't be complaining. What's your not a valid? Yeah, whatever. It is. If you can run it, you should be able to tell that it's valid. All right. Tell me, what did I get out of this? Are any of those missing values preserved from the left or preserved from the right in common here? Nope. Why? Because the ones that are missing from the left are in B. The ones that are missing from the right are in A, but they're not in that intersection. What's in the intersection? Things that are preserved from both directions. Right? Things that have values going all the way through in both directions. So yes, you can do union, you can do intersect. Let's do that so that it's happy about it. Right. Okay. So, one grand unified data model right here. Right. I'll go ahead and put that in the notes. So remember, you can do basically any set theory based operations. Why? Because RDBMSs, what does that stand for? The R in that is a relation. What is a relation? A relation is a definition on a set. All right? It's a subset of the Cartesian product, a full outer join, a full cross join. Everything that you know about sets, you can basically apply it over here to SQL because Edgar Cod designed it that way. Right? Okay. What I want to do now is switch gears. We've been working with this database up to this point, but I created the database and I gave you the data, and I gave the data without really talking about how was this database actually created. And so that's going to be the next thing that we're going to do. We're going to create our own database. We're going to design it, and we're going to implement it. Okay? So we're going to implement it based on the Java classes that we've already written. So we're going to create a database to model the account Java classes problem. Right? In other words, like we have accounts, annuity, right? Account, annuity. What else did we have? Stock, right? We had P person as an owner, right? It's emails of a person, etc. Right? Okay. So just to remind us of what that looks like, where's my? There we go. There it is. Okay. And again, if you are struggling with your design, make sure that you are going back to the UML diagrams in Lab 5. They're very informative. They say, here's an employee. Here's a different type of a specific type of employee. Here are the questions that we can answer up here in the employee class because we have enough information to do so. Here, down here, we don't have, or up here, we don't have enough information to determine how much they're paid because salaried employees are different and hourly employees are different. So what's the solution? You make that abstract, right? If you're following the examples that we've given in class and given in a lab, you're going to have a lot easier time with your design, okay? So we've got the asset class over here. We've got the stock and the annuity class down here. The terms and the monthly payment, those are down here in the annuity class. Up here in the asset class, we didn't have enough information to determine what the value was because that requires terms and monthly payments and the number of shares and the share price down here in the subclass, right? So consequently, that is italicized and it is an abstract class. This is not an what do I want to say? An inheritance here. This is basically a uses, right? Get owner, well, the asset has one owner, right? And do I have emails here? No, I don't. But I do have it in there. I don't, well, let's do that, actually, right? Hopefully, you did design it like this. If not, then you'll want to go back and fix it. Private string email, right? Okay. Is that enough, especially for your project? Right? Oh, okay. Well, it's enough if I did an email like this, right? foo@bar.com, comma, blah@baz.com, comma, right? email@email.com, right? Is that a way to represent the emails, right, as one big giant string with a delimiter in it? Absolutely not, right? So how should I represent this? It's a list of emails or a collection of emails or a set of emails or whatever, right? List of strings. There we go. And let's go ahead and import that. And I'm not going to change my, because I don't want to break any code here, I'm not going to change my constructor here other than to initialize that array list, new array list. There we go. And bring that in. And the reason I'm not going to do that is because I don't want you to have to create the entire list before you create a person. I'm going to instead give you the ability to add that later on. Just like we did with the book and the author, I didn't require somebody to have an author, all of their books, because later on in the file we find that same author, we want to add that book. So I'll go ahead and say public void, add email, string email. This dot emails dot add email. There. It's no longer an immutable object, but that's okay. All right, immutable objects are great, but there's a limit. I want this to be more usable, so I'm going to let you add emails. Think about your classes, especially for this one, right, and the last one. And is there a class that should have a collection? And I don't know what the collections, what belongs in the collection up front, but if you add this ability to add it later after you've created that collection, that object, right, that's going to be a lot more usable. Right? Add email. Okay. There we go. All right, so let's go ahead and design the database to do this. Right? Obviously, I'm going to want an email and a person. Let's start there. Right? A person, which is going to be an owner, and an email. Okay. Let's go ahead and create a person first. Actually, let's go ahead and let's go ahead and create the email table first. What should that look like? Now, to create a table, it's very, very straightforward. You use the keywords create table. Who would have thought, right? Something that actually makes sense here. Create table, email. And then you open it with a parenthesis and end it with a parenthesis and an ending semicolon there. Anything that you put inside this is going to define that table. Right now, it's not compiling, or it's giving me an error right here because I've actually not created anything inside that table. Let's take a look at this table over here. Right now, what's the first thing? What's the common thing that you see in every single table? What's the very first thing that you should do? Period. Every single table has a what? Primary key. Do not proceed unless you put in that primary key. Now, I call this capital E email table. That's a more modern convention, right? If you wanted to go with this old school convention of lowercase everything, that's fine too. But let's go ahead and go with a modern convention here of capital E. Why did I do that? Because I'm thinking forward to Java and my database. I'm going to want to connect those two things together. If I'm using Java casing conventions, and I had an email class or something like that, then there's even less guesswork because I'm using an upper camel casing convention in my database, right? Okay, so primary key. To do that, I'm going to add email ID, right? And I'm going to use lower camel casing conventions here, just like I would in Java. Int primary key, not null, auto increment. Now let's walk through that before we continue. Again, lower camel casing convention. I lowercase the e, and then I slap an ID at the end. Right? If you were using an old school convention, it would look something like that, underscore ID. Right? I'm not old school like that. I'm more modern. Right? It's going to be an integer. Do not use strings. Right? You can use string. You could use a double. Right? Don't do that. This is a unique ID. Right? If you use a string, now you have casing conventions to worry about. Right? ABC all lowercase is not necessarily the same thing as ABC all uppercase. Right? ABC all lowercase and ABC all uppercase, they might end up being the same if you've shut off casing conventions or case sensitivity. What about doubles? Right? 1 divided by 3 times 3. Is that equal to 1? Not necessarily. Right? In fact, there are some doubles that aren't even representable. 1/3 is not representable by a double. It'll go 0.333333 for 17 digits, and then something happens at the end. Either it becomes 0, it becomes 2, 1 less than 3, or it becomes 4, because it's not exactly representable by a floating point number. Why? Because floating point numbers are only 64 bits. 1/3, 0.3 repeated, that's infinite. It goes out infinitely. We only have 16, 17 digits of precision. So consequently, I'm going to use only integers. Okay? Second part of this, how do you get it that it's a primary key? You do it, all right? Primary key. Not null. Right? I'm going to say that this is not nullable. What use would it be to have, say, a game with a null key? Right? That's weird, right? That would be saying that it's a non-existent game, right? In any case, it's a primary key. So even if you had a game that had a null value for its primary key, that's the only one. That's it. Right? Nobody else can have that value, null, because it is primary and unique. Auto increment. Make sure that you are taking advantage of the database design. Right? The key management is a very difficult problem, one that is solved by the database. Let it do its job. Auto increment. So that if you create a new game or email here, it'll receive 1. Then the next one will be 2, 3, 4, 5. Right? It'll take care of that stuff for you. Right? You don't have to worry about those details. Okay? It'll also make sure that they're all unique. Right? All right. So what else is what else should I put in an email table? Do you just need the ID 1, 2, 3? What else would you need? Hint, hint. What's my email? There we go. So what is that? What would you call that thing right there? I'm not going to create an email class. You could if you wanted to, right? And a lot of people would, but I wouldn't. Why? Yagni, you ain't gonna need it. Right? So over here, I do need a table though. Right? Help me out. What would you call that? What do you call that thing? What do you call that thing right there? You call it an email, yeah, but an email address. There we go. All right. Now, what type is that? Varchar, right? 255. You can use the keyword string. I have no idea whether it's an alias for. It's just going to be an alias for varchar, maybe 255. I don't know. You'll see this all over the place. Why 255? That's big enough, right? If you go back to the 1970s, where everything was measured in bits and bytes and kilobytes rather than megabytes, terabytes, gigabytes, right? Then 255 has a very special value, right? It is 1 less than 256. 256 is 8 bits exactly, right? 8-bit addressable. So why one less? Well, you start at 0. Or if you're representing a string, those coming from a C background. If you have a string, what needs to be at the end of it? A null terminating character, exactly. And so we only have actually 255 spaces for it, right? So there's some history there, right? Varchar. Should I allow, if I just left it like this, the address could be null, right? It's nullable. You're allowed to create an email address record that has no address. Does that sound right? Why would you create that record to begin with if you don't have the email address? So I'm going to come over here and say that it's not nullable, not null. Right? All right, that's good enough for now. But I'll put in here how to connect on email to a person. Well, to do that, first of all, we need the person table. Okay. So create table person. Right. We're not going to be able to complete this today, but we can at least get some things in here. For example, what's the very first thing you should put in here? Primary keys, right? If you find yourself doing anything else, stop. You're doing it wrong, right? It should always be primary key int not primary key not null auto increment, and it should be named after the table with an ID slapped at the end. The reason that you do this is that it gives you second normal form for free, which we'll talk about normal forms later on. Right? Okay. What else defines a person? Yeah, okay. Should I just have name? Name, which is a varchar, 255. Right? That's not what we did in the Java class, right? We thought, oh, well, you should probably go ahead and split up the name and the first name. Why? Because sometimes you want to go last name, comma, first name. Sometimes you want to go first name, last name, space last name. If you give valid names to these things, then you know which one is which. Last name, first name, or first name, last name. Doesn't matter. Why doesn't it matter? Order doesn't matter in databases. Right? Okay. As I have it right now, what is the default value there? Is it allowed to be null? Yep. Only if you slap on not null is it not nullable. Okay, well, certainly the last name should be there, not null. Everybody has at least one legal last name for legal purposes. Some people don't really have a first name, though. Right? Some people are just single-named people. Right? It's usually a pseudonym, right? But maybe there are some cultures where there is no first name. They just go completely by their last name. Right? So I'm going to go ahead and say, yeah, okay, this can be null. Right? This allow this to be null. I'm going to put that in a comment to remind myself, yes, I didn't just forget not null. This is a conscious decision here. I'm not going to allow this to, I'm going to allow this to be null. Right? They can have just one last name. Finally, the last thing that I'll put in here is date of birth. Right? Now, date of birth over here in Java was a what? A local date. Why? Because that was built into the language. And yes, there is a date built into SQL. Do not ever use it. It sucks. It is terrible. It also varies greatly from one SQL to another SQL. It is absolutely terrible to work with because there's no consistency there at all. Right? I'm going to make this into a varchar. I don't know how big, but I want it to be of the form, 0000. That's the year, 4 digits for the year, hyphen 00, 2 digits for the month, hyphen 2 digits for the day. Why do I want it like that? Because that's the only proper way to do it. What is today? Today is 2024 0304. Why am I putting leading zeros in there? And why am I putting the year first, then the month, then the day? That is the only proper way of doing it. This is the ISO 8601 standard. Right? Computer scientists are the only ones that get it right. Europeans get it wrong. Americans get it wrong. This is the only proper way of doing it lexicographically. Why? Because it is lexicographically orderable. Leading zeros and the most significant value first allows you to do string comparison to order things by date. Right? That's the ISO 8601 standard. Right? Oh, and by the way, I've seen people in some of their test cases have that. That's not the ISO 8601 standard, and so we threw those out. Right? If you did that, we still gave you most credit. Right? That is wrong. It is hyphens. Right? So proper formatting. We'll pick it up there next time, and I want to make sure that I preserve this.